solve the equation in the problem that's given here, we will approach it in an almost identical way to the way that we approached solving in the basic trig page. The key difference is the 3 that we find inside of the sine function. First, I want to consider what that 3 does. We've seen it graphically as a number that changes the period of a graph. So if the blue graph were to be sine of x, then this red graph should have 3 times as many periods as the blue graph. So if I was to try to say, find out when will the graph hit some value, I should come up with 3 times as many solutions. And we can see that that is the case. The red graph crosses 1, 2, 3, 4, 5, 6 times, while the blue graph only crosses 1, 2 times. So we should expect to get 3 times as many solutions. But instead of graphing it on your calculator and finding the solution, I want to also be able to solve this problem by hand. So to solve this problem, we're going to begin the same way we began with solving a basic trig function. We add 4 to both sides, we get 5 is equal to 10 times sine of 3x, and we divide by 10. At this point, we have now isolated the trig function sine 3x. And we want to ask ourselves, just as we did in the previous problems, for what value of x will sine have a value of a half? And we know that sine has a value of a half when, on the unit circle, we look at pi over 6 and 5 pi over 6. So what I'm going to do is I'm going to say, well, I know that 3x can be 5 pi over 6, or 3x could be equal to pi over 6, which means that x should be 5 pi over 18, and that x should be pi over 18. And if you plugged in pi over 18 into sine of 3x, you see that the 3 that's multiplying there will get rid of the division that we just did. So what we're doing is our answers are kind of compensating for the 3 being in the problem. They're getting 3 times smaller. However, the other consequence of the 3 being there is that our answers don't just come between 0 and 2 pi. We need to look for all the things for not just x, but for 3x initially. So we look between 0 and 6 pi. So our answers should not have been simply 5 pi over 6 and pi over 6. We should also have had what happens when we go around another rotation, 13 pi over 6, and one more rotation, 25 pi over 6. Notice here I'm just adding 12 pi over 6, or 2 pi, to come to the next answer. So then we should also here have 17 pi over 6 and 29 pi over 6. And each one of these will give us a new solution that we get when we divide by 3. We have 13 pi over 18, 25 pi over 18, and that is where we can see the 1, 2, 3, 4, 5, 6 answers that we would have expected. And so each time that we're looking to do this, you must first decide how many answers you should look to get, expand the view of the period that you're being asked to find based on the multiplier, and then in the end, find all possible solutions in the expanded period before dividing down into the domain that you're actually asked to find.